exponent rules. So hopefully this is somewhat of a review for you. But we have two rules that you're going to need to know. One is called the product of powers property. So I have a power, a to the x, and another power, a to the y. And those two things are being multiplied, right? That's why we're talking about it being a product of powers. When you have bases that match, the result is that you add the exponents. So I want to go through some examples. If I have 2 to the 4th times 2 to the 3rd, do I have matching bases? Yes. If I have matching bases, what is that rule telling me? To add the exponents. So that would be 4 plus 3, which gives me 2 to the 7th. Can I actually solve what 2 to the 7th is? I can go to my calculator if I want to, right? 2 times 2 times 2 times 2, or just 2 to the 7th, 128. If you can calculate the number, then calculate the number for me. Now, why does this rule work? Well, let's think about what's really going on here. 2 to the 4th, we could write as that, correct? And 2 to the 3rd is this. Yes? So if I am multiplying those together, don't I have 2 times 2 times 2 times 2 times 2 times 2 times 2? That's 1, 2, 3, 4, 5, 6, 7. That's where the 2 to the 7th comes from. Does that make sense? So that's kind of the long way of thinking about it. We're just going to use the shortcut of adding them together. What if I have something like this where they have coefficients? There's a 2 and there's a 3. I'm going to multiply the coefficients. 2 times 3 is 6. And then I have k to the 1st, right? If it has no exponent, it's a 1. And k to the 2nd. So what is that going to give me? K to the... Here's I have 1. Here I have... So, k to the 3rd. And that's my answer. So?
Wait, so you add it both times?
What do you mean you add it both times?
When the base is the same, then you told us to add the exponents.
Mm-hmm.
And then for number 3, the base wasn't the same, so you multiply.
Good question. The base is the same. The base of the power is just k. If the 3 was a part of the base, it would look like this. That makes the 3 a part of the base, and we'll talk about that in a few minutes. But as it is, 3k squared, the power is only that part because that's the only part that has an exponent. It doesn't go to the number in front unless it's in parentheses with it. Okay? So let's practice a few more of those to make sure we get it right. All right? I'm going to come back to 4 and 5. I kind of wish those were towards the end. But let's go to number 6. What's the coefficient here? 1 times 2 is 2. And then my powers, I have x to the 3rd and x to the 3rd. What am I going to do with those exponents? Add them. So I have 2x to the 6th as my answer. Not too bad? What about number 7? I have no coefficient here, which means it's a coefficient of 1. 1 times 3 is 3. And then I've got all sorts of r's. I have 2 here, 2 here, 3 here. So how many total? 7. 2 plus 2 plus 3. What about here? 1 times 3 is 3. X to the what? 5th, because I have 2 here and 3 there. And what am I going to get here? 3 times 3 is 9. X to the what? Because this has an exponent of 1, so 1 plus 2 is 3. So? Let's go up to these guys that have more than one letter. I'm still going to start off looking at the coefficients. This is a 2. What would be in front here? 2 times 1 is 2. Now I'm going to look at the x's. I have x to the third and x to the fourth. If I just look at those guys, that gives me x to the what? 7th. Now I'm going to look at the y's separately on their own. So I have y to the third, that's 3 y's, and this is 2 y's, so I have y to the 5th. Okay, you try number 5. Question, yes?
For number 9,
Mm-hmm.
if the base are the same, then why are you multiplying?
Remember, the 3 is not a part of the base in either one of those. It's only a part of the base if it's in parentheses with the letter. If it's not in parentheses with the letter, it's not the base, only the letter's the base. Okay? All right, what's my answer in number 5? 4 what? Let's go alphabetical. X to the what? There's 4 x's here, and there's 1 more there, so that means x to the 5th. How many y's are there? 1, 2, 3, 4. And z's? 2. So that's what my answer looks like. Okay. Now let's look at our second property. The power of a power. So instead of this one where I had 2 bases, and I kept the base and added the exponents, this time how many bases do you see? I only have 1 base, right? Pretty much whenever I have something in parentheses, this is saying you're basically going to distribute that exponent, and you're going to end up multiplying them instead of adding them. So for example, number 11, if I distribute that exponent through the parentheses, I'm not going to multiply it by the 4, I'm just going to multiply it by the exponent. So that's going to give me 4 to the what power? 12th power. Can I plug that into my calculator? Yeah. 4 to the 12th. That is a gigantic number, isn't it? Huge, huge number. Well, I want to see 4 to the 12th there, and then you can go ahead and write 16777 So, as you're showing me your work, I do want to see this as well as this. Okay? Now, why is that the case? Why do we multiply here? Well, let me show you the long way of thinking, just like I did up here in number 2, so that you can understand it a little better. If I have something that's being cubed, doesn't that mean that I take it and I multiply it by itself how many times? 3 times? Isn't that what cubed means? So if I have 4 to the 4th cubed, I have 4 to the 4th times 4 to the 4th times 4 to the 4th. Well, this right here is 4 times 4 times 4 times 4, right? This is 4 times 4 times 4 times 4. And this is also 4 times 4 times 4 times 4. They're all being multiplied, so how many do I have? 4, 8, 12 of them. It's 3 groups of 4 4s. Kind of crazy, huh? So let's look at the next one. This one is a little bit different because if we're talking about the bases that we were confused about earlier, look very carefully at this 3. This 3 is not part of the base for this 4, but it is a part of the base for the outside 4. Why? Because it's in parentheses. It's not in parentheses with the m for this 4, but it is for this one. So here's what's going to happen. I have to take this exponent and I have to put it on the 3. That gives me 3 to the 4th. But then I also have to distribute to the m, and the way I distribute to the m is I multiply it by the exponent that's already there. So what's 4 times 4? 16. Do you think I should leave my answer that way? What should I do? I should actually calculate what 3 to the 4th is, and that's 81. So I would say that my answer here is 81 m to to the 16th. Kind of makes sense? Okay. So if I look at number 13, I have this exponent out here, this 3. I need to distribute it where? To the 4. That gives me 4 to the 3rd. To the u to the 3rd, what am I going to do if it already has an exponent? I multiply. 3 times 3 is 9. And then it also has to go to the v, so v now has an exponent of 6, because I multiply those. Should I leave my answer like this? No. What is 4 to the 3rd? So I have 64, u to the 9th, v to the 6th. So? All right, you try number 14. X to the what? 6th. Y to the what? So it looks like my answer should be 16x to the 6th, y to the 6th, correct? Yes? No? Okay. Now I'm going to combine the rules in a few problems. So right here, what do you think I should do first? Distribute what? I need to take care of the parentheses, right? So I'm going to leave this negative 2x squared as it is. And I'm going to simplify this. This would become x to the what? 20th, because I would multiply them, right? I'm distributing an exponent, basically. So I'm multiplying them. Now, I don't have any parentheses, so I have a problem like using this first one, this first rule. So negative 2 times what's the coefficient here? 1. That gives me negative 2. And if I have x to the 2nd and x to the 20th, I'm not distributing an exponent, so I'm not multiplying, I'm adding. So that's going to be x to the 22nd. There's a lot of 2's in that problem, aren't there? 2, 2, 2. All right, number 16, end of the 3rd. That guy's going to stay the way it is. But this negative 2 is going to be raised to the 4th power. Now, here's a question. When I raise a negative number to a power, am I going to write that like this or like this? Top or bottom? Why?
Because it's separate from negative, so the exponent will be a negative.
Is the negative inside the parentheses? If it is, then you want to write it like this. Okay? And these are two different things. This one, if I were to translate that, that becomes negative 2 times 2 times 2 times 2. This one is negative 2 times negative 2 times negative 2 times negative 2. There's a slight difference there. You couldn't see my work there. So this one only has a negative on the first one. This one has a negative on all of them. So I have negative 2 to the 4th, and then I have n to the what? I'm distributing an exponent, so I'm going to multiply. So? Okay. My coefficient here is 1. So I have 1 times 2 to the negative 2 to the 4th. That's what? Negative 2 to the 4th, and I'll simplify that in a minute. But then I have n to the 3rd and n to the 12th, so what does that equal? N to the 15th. I think I can go one more step. What is negative 2 to the 4th? Negative 2 times negative 2 times negative 2 times negative 2 is positive 16, according to my calculator. So my final answer is going to be 16 n to the 15th. Okay? All right, you try number 17, and then I'll talk to you about these fraction ones. All right, so I think I have 2 to the third, m to the 4 times 3 is 12, and n to the 4 times 3 is 12, times an n. What is 2 to the third? 2 times 2 is 4, times 2 is 8. I have m to the 12th, and n to the what? 12 plus 1 gives me 13. Okay. All right, one last rule that I want to talk to you about. And I should have titled it, but I didn't. But it's the quotient of powers. Let me show you how it works the long way, and then hopefully it'll make sense what we're doing. So, first thing I would do is I would look in front. There's no coefficient on the top, so what does that mean? It's a 1, right? Can 1 over 4 be simplified in any way? So I know it's going to be 1 and 4. I may or may not need to write the 1, but I know it's going to be 1 and 4. How many n's are on top?
4.
So that's what I've got on top. Here,
2.
2. Can anything cancel?
Yeah.
I can cancel those n's. I can cancel those n's. Do I have any n's left to cancel out?
No.
So on the top, I have 1 times n, which is n squared, or 1n squared. Doesn't matter if I have the 1 or not. On the bottom, I have a 4. That's my answer. What would be a shortcut to get to here? How could I take these guys
Divide it.
and do a shortcut?
Divide it by the equal denominator.
Not divide it by. Subtract. The top exponent minus the bottom exponent. Why are you subtracting? Because those are the ones that would cancel out with the bottom. Okay? So, let's look at that here. This one isn't quite as simple because there's a little work that I have to do on the bottom before I can do that. So, whoops. I have my x on top. On the bottom, I have what? 2 to the 4th and x to the 4th. So in other words, I have x over, what is 2 to the 4th? 16, I think. X to the 4th. Now I have an x on the top and on the bottom, so I have to think in terms of this. If I have x on the top and on the bottom, I have 16 x, 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 x. What happens? This is going to cancel with one of these guys. So there's nothing left on top. What do I put if there's nothing left on top? You put a 1. And then on the bottom I have 16x to the what? 3rd. So whichever side the larger exponent is on, that's where your x is going to remain. See if you can do number 20. Oh, that's a good point. That's an ugly question. Let's make this an m. I didn't even notice that. Let's make this an m and then solve it. Is that better? Sorry about that. You're right, though. If it was n to the 3rd over m to the 2nd, it wouldn't be able to be simplified at all. Is this what you got so far? So what's my answer? Do I need to put a 1 on the bottom? No. 1 on the top? Absolutely. 1 on the bottom? You don't have to. Okay? So if you wrote m over 1, I wouldn't take off points for it. Okay? All right, let's look at this one. This has a negative out in front. That's meant to try and scare you. But you know what it does? It just stays there. We're not going to do anything with it. Let's look at coefficients next. I'm going to draw my fraction bar. There's no coefficient on top, which means it's a 1. 1 over 4 doesn't reduce, so that's going to stay. If it was like a 2 on the top, 2 over 4 does reduce, doesn't it? So I would reduce that appropriately. Now let's talk about the u's. I have 4 u's on top and 4 u's on bottom. Now if I see what's going on, I don't have to write out all those u's, right? Cancel, 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 cancel. There's not going to be any u's left. How many v's are on top? 4 v's on top, and on bottom? So let's see. Cancel, cancel, cancel. So I have a negative fraction, because that doesn't change. On the top, I have 1 v. So I can just call that v. And on the bottom, what do I have? Just the 4. That's it. By the way, the negative sign doesn't matter where you put it, whether you put it in front of the fraction like they've got it, whether you put it with the top, or whether you put it with the bottom, as long as you only have 1. You can't put it with the top and the bottom because that actually makes a fraction turn positive. All right, you try the last one. Okay, so I think I have 3 u, 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 v, v, v over negative 2 v, 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 right? And yes, you can use the subtraction if you want to. So I think when I cancel things out, I have 3u to the 4th over negative 2. Okay? Any questions? All right, happy studying.